Okay, so when we're completing the square and it's an odd number, don't it's still the same. It's still the same structure. Okay, so reminding you here, like when we had x squared plus 4x plus 2, what did we first do? What number did we first consider? Yeah, we considered that 4x. So what are we going to consider here first? Yes, very good. Okay, so this is going to be weird because you guys are like, Miss Johnson, what does half an X look like? Okay, so remembering that she's in a quilt shop and you can do half of an inch, right? Or half of a measurement. So if you can just be so kind as to imagine this with me. Hold on, let me erase this over here. Wait, where'd it go? Here it is. Let me just erase my highlighting so I can get this. Okay, so I'm going to grab this. This is going to be X and put it here, right? Okay, I'm not going to pull down my complete boxes because it's going to look a little funny. So I'm just going to draw them in. And I want you to imagine what this actually means. Okay, don't judge me on my drawings. So if I have 7 X's, how many go on each side? If I have 7 X's, how much go here and how? Yes, 3.5. So Ms. Johnson, you want me to draw 3.5 of them? Yeah, so here's one of them. Here's 2 of them. Here's 3 of them. Now look, I'm not going to draw, they're supposed to all be the same, no judging, right? So instead of drawing half this way, like I'm not going to draw half of one this way because then I won't ever make a square, right? I'm going to draw a half the other way, like lengthwise. Does that make sense? So I'm going to go in here and draw a really skinny rectangle. See how like skinnier he is? I know they're all supposed to be the same again, no judgy, right? So can you imagine what my length is going to be across the top here? What's my length going to be for this big square right here? How long is this going to be? Well, Ms. Johnson, this is going to be X for sure, right? And then over here, exactly plus 3.5, Ms. Johnson. Yeah, I like fractions better, so I'm not going to write it like that. I'm going to write 7/2. If you are considering, Ms. Johnson, should I like fractions more? Mathematicians tend to deal with fractions better because think about, well, you'll see in a second. Okay, so then I'm going to do the same thing here. So again, I go here, again, no judgy. Actually, I'm just going to just go X plus 3.5. Which in this case, I like 7/2 better. So let me do that. So here's 1, here's 2, here's 3, here's half, and it's like skinnier, right? Okay, so how many squares would be here? Oh my gosh, you're totally judging my rectangles. I see you. Okay, here, how many is going to go here? So wait, don't answer this question, okay, until you go up here. How did we get 4? How did we get this 4? Yes, we multiplied 2 times 2 gave me 4. Exactly. Wait, can we just check the 9 really quick? How do we get this 9? Yes, -3 times -3. Exactly. We got 9. Okay, Miss Johnson, this is really weird. Okay, what are we going to do here? So I'm going to write that I'm going to multiply this, and I'm going to go 7/2 times 7/2, also known as squaring. Okay, so I'm going to write 7/2 squared. Okay, this is why I like fractions better than decimals. I can square this fraction faster than you can type into your calculator 3.5 squared. Okay, so when you square a fraction, you're squaring the top and squaring the bottom, so that therefore it's just 49/4. See, much faster than 3.5 on a calculator. Here, let's test. 3.5 times 3.5. You see how long that took me? I don't care that it's 12.25. I really care that it's 49/4. That's what I care about. Like it's a value, which happens to be 12.25. So far, so good. Okay, so first, write me the vertex of, okay, so first write me this as an area of a square. what would this be written as? Now, like I'm asking this, I want this like this. You guys got this. I know it takes a long time to type. Exactly. So part of it is x plus 3 quantity squared. Good. So I got someone to type one side of it. So let me get that side. Can someone get me the other side? Can someone, oops, I don't want to save it. Right here. Shelton, isn't it faster for you to just type it out? It is, but I like doing this because then you guys believe me that, you know, I'm not writing these. Can you, someone write out the other side, this whole other side right here? I know this is like the messiest thing ever. I should have just copied it. Right, you guys got this? So I got x squared, yes. How many x's do I have? Wait, what? I do not have 4 x's. I do not have 8 x's. Hold on, all together. How many x's do I have all together? Nope, all together. Yep, I have 7 x's. Right? Because that's what we said, and that's how you divided them by 2 to get me this. Does that make sense? Okay. Plus this guy, right? And some of you are like, Miss Johnson, I want that to be a decimal. Just trust me for a second. Trust me for just a second. Okay, but they didn't give me this. Okay, they gave me this guy. They gave me this guy. Right? So just like we did before, we start with what we have and then we go to where we want to go. So how does this compare to this? X squared plus 7x plus 10. Okay. So if you don't remember what 10 is in terms of fourths, okay, so 49 fourths, and I want to go to 10, 10 is just 40 fourths. 10 is the same as 40 fourths. So I want to know, what did I do? What do I do to get from here to here? What do I do to get from here to here? Okay, from here to here, from here to here. So if I know that 10 is the same as 40 fourths, right? It's just the same thing as 40 fourths. What did I have to do to 49 fourths to get back to 40 fourths? Yes. Subtract, good. Subtract what? Not 12.25. Talk to me in fractions. What number belongs in here? Subtract what? 49 fourths minus what gives me 40 fourths? 49 fourths minus what gives me 40 fourths? 9 fourths, actually. So if you think about pizza, right? If you think about pizza, it goes like this. I had pizza and I cut them up into fourths. I had 49 slices, right? So then how many am I going to have to eat in order to get back to 10 pizzas, 10 whole pizzas? So just subtract. Remember, denominators have to be the same. So you want me to subtract 9 fourths, Miss Johnson? Yeah, just subtract 9 fourths. Now here's the thing. If I subtract 9 fourths from one side, what am I going to have to do? Yes, subtract it from the other side. So that 9 fourths gets subtracted here. And then this, I'm just going to be a little bit on the lazy side and copy and paste. Oops. And I'm going to put it right here. Both sides, always subtract from the both sides. And so then now I have this thing. Here's my vertex form. Equals. Right? x plus 3.5 squared minus 9/4. As weird as this looks, couldn't you pull off my vertex from here? You guys are like, yeah, it's right there and right there. Okay, so let me pause really quick.